Welcome to Inside AI, a podcast from the EPFL AI Center. I'm your host, Marcel Salaté, professor and co-director of the EPFL AI Center. Each episode brings you fascinating discussions with brilliant minds from EPFL and across the global AI community. From groundbreaking algorithms to ethical considerations, from technical innovations to real-world applications, we explore the technology that's transforming our world. Whether you're an AI researcher, industry professional, or simply curious about the technology that's shaping our future, join us as we venture inside AI. Today I'm speaking with JP Fricker. But before we do that, just a reminder about the upcoming Applied Machine Learning Days, AMLD 2025, on February 11th to 14th at the Swiss Tech Convention Center at EPFL in Switzerland. It's 3 days of conference, amazing keynotes, parallel tracks, tons of networkings on all kinds of aspects from business applications, science, startups, policy discussions, including a 4th day of hands-on workshops. This is the most exciting time ever in AI, so join us for the 9th edition of AMLD at EPFL. Tickets and full program are available at 2025.appliedmldays.org. Now back to the conversation with JP Fricker. JP is one of the co-founders of Cerebras Systems, a company known for pioneering wafer-scale AI hardware. Before helping launch Cerebras in 2016, he was part of the engineering team at C-Micro, a startup later acquired by AMD, where he worked on high-density server architectures. JP is an EPFL alumnus, and he has focused much of his career on designing and optimizing hardware solutions for high-performance computing environments. Cerebras is currently on an extremely impressive trajectory, having produced the largest and fastest AI chip in the world. And in this episode, we dive deep into his journey as a founder in the AI chip industry, and we also look at the rapid acceleration of AI development in recent years. And we'll get his unique perspective on navigating the startup landscape during this quite transformative period. I hope you enjoy the conversation. I'm here with JP Fricker from Cerebras. JP, thanks so much for joining us.
Thank you for having me, Marcel. Thank you.
So I think I want to begin with Cerebras and your role in it. So can you walk us a bit through the founding of Cerebras and how that came to be? How do I have to imagine this? It's probably not just 5 guys sitting around with nothing to do and deciding to create an AI chip company.
Actually, it's not that far from that. It's not that far off from having time. So we were friends who had worked together in the past, but just happened that we took different roads and found ourselves in a time in our career where we had some time. For myself, for example, I was in a company that got acquired by Dell in the end. And when we do an acquisition in the US, it can take some time. But during that time, when the announcement is done to do an acquisition until the acquisition is actually complete, engineering typically stops. What I should say is that you cannot make new investment, you cannot hire, you cannot fire, and things are basically steady, business as usual, but you cannot really evolve. And in my position, I was about to acqui-hire a company and create a new project, and they told me, no, you cannot do it. And so I had time. They had my phone number, they could call me if they needed to. So as an engineer, you get bored very quickly, not to do anything, and started to talk to friends. What are you doing? What's going on? Where are you at? And turns out that some other friends were in a similar situation with some spare time. It was after a venture that they had done, and some others were able to take some time for themselves. And we started talking, just around the coffee first. and having some ideas what could be done in the future. And you do that maybe once a month at first, and then you do it every other week, and then you continue to do it a couple of days a week until it becomes every day. But we didn't have an office. We didn't have any special equipment or facility to do that. So we went downtown Palo Alto, where there are good coffee shops and good restaurants, and you start there, but then you don't want to spend the entire day in a coffee shop or a restaurant. We found out that the nearby library, a public library, had rooms that were you could rent them for free, or reserve them, I should say, and only for 2 hours. But since we were 5 or 4 for some sessions, we could basically reserve there for the entire day. So we spent our days in the public library figuring out what could be an interesting adventure. We were pretty broad in the ideas, but ended up finding that with the background that each one of us had, that is computer architecture, more specifically microprocessor architecture for some of my colleagues, co-founders, also software architecture wasn't there, and for myself more system packaging and system partitioning and architecture. We thought that we should do something in that field. We all had done telecommunication devices or networking devices in the past, computer in the past, switches, storage devices as well. And so the field of computer seemed to be adequate for our background. And then we saw some advances in very early stage machine learning, not as early as the 80s, which was what my first encounter with machine learning was at the LAMI. There were some machine learning expertise in the lab here at the EPFL. But since then, it was pretty stagnant, and I haven't heard back of it. But at the time, in the fall of 2015, we started to hear advancements in AI and large language models. But it was the very, very beginning of it. And we were intrigued by how the workload of large language models, more specifically at that time, was in general neural networks and deep neural networks, and how computers could actually tackle that problem. We realized that CPUs were not good. We realized that GPUs were better, but not as good as they could be. And we started thinking about what we could do better. What type of architecture would be more appropriate to solving the mathematical challenges that deep neural networks expose. One of our co-founders is a mathematician by training and also a computer scientist, and he understood the math very well. Another one was an architect for microprocessor at AMD for just one generation there, and he understood that very well. Our CTO was a computer architect who worked at Sun Microsystems for 3 generations of processors. And we thought, okay, I think we have a path here to see how we could map the math to hardware, and then take advantage of that hardware with some layers of software to make it simpler. We quickly found that the GPUs, even the one at the time and the one that have evolved since then and today, are a little bit inappropriate in their architecture. They're made of an evolution of components that gets packaged and repackaged over generations, but not fundamentally designed for the problem at a given time. They are just an evolution of graphic cards that, yes, improve drastically for high performance computing and so on. Some workloads that are not AI, and they tuned them recently to be able to be better at AI. But we quickly found that the bandwidth to memory and the communication among the various compute element was going to be a big bottleneck as the type of network evolved and grew. So we saw an industry trend. We saw a demand for that trend, basically large problems would start to be um, solved or I would say served by some of the AI products or the products of the AI research at the time. That started to become a business reality. And so we saw, the business might be there. So people might actually need those extra compute performance element, and we should probably think about how we could tackle that. So we liked that idea more than many others that we looked at, but it needed a very big investment. And at the time, you need to remember that there was no funds available for any hardware startups. Every VC in the Valley and that we knew of were only investing in software startups, but not in hardware. Hardware was the no, don't invest there. It's too hard, too expensive. Don't do it.
Incredible, because that's less than 10 years ago.
Yeah. And the funding landscape was very dry, and we were somewhat concerned that it would take us months to raise funds to start this. Remember that when you do want to create a new chip like this, just the tape out of a chip is tens of millions, right? It's very, very expensive. So you need to raise enough money to go through at least one, if not two, cycles of a tape out, plus the manpower to actually create the design and get it implemented and then test it. So we had the idea. We didn't have a slide deck or a business plan on anything, but we had the idea, and we knew that we needed something that was far more performant than what existed. So not increasing by a couple of percentage the capacity or the performance of a solution, but being a little disruptive. Because if you don't disrupt, then you're just an evolutionary solution. And for an evolutionary solution, we found out that you just wait a little bit and the competition just catches up. And so you cannot really make a dent in the market. Okay, so we wanted to do something revolutionary. And we went with the idea that we could make a GPU that, or equivalent, that would be 1,000 times faster than what existed. Obviously, many people didn't believe us. Like, how? Who are you? Why? And we had the chance to actually be together with our present CEO, Andrew Feldman, who is someone I worked with at Yago Systems and Cabletron Systems, and then spun off at Riverstone, who got bought by Lucent and merged with Alcatel, all the same company in a way that was doing networking gear. And early on in the Silicon Valley, I was able to work with him. We knew each other well. And he's a very good storyteller. He's the real CEO that can convince you of anything. In this case, he was actually having a very good story with what we were coming together with. And together with him, we went, again, with no presentation whatsoever, to a VC that he knew, just to have a talk, just a 15-minute talk, a courtesy talk. And after 10 minutes, we were already talking term sheets to fund us. And we had no idea how much we wanted and what the term would have to be. And when we saw that, we then stepped back and said, oh, hold on. We will discuss this among the founders, at the time, not yet founders, but the small team that we were, and we'll get back to you. So we took about a couple of weeks, I believe 2 weeks, to put together a story, write it down, have a fil rouge through the story, perfect a pitch basically, and then went back to the VCs. And the good thing in Silicon Valley is that they're all in the same area, either in San Francisco or down in the south area of the Bay, near Palo Alto, Menlo Park. And so you go on a road, you go to a coffee shop, wait for your turn, and then oh, now it's our time. Okay, you go to the PC and they hear you for 15 minutes. Sometimes it's just a couple of people in a room. Sometimes they have 50 people on a Zoom call, and you do your pitch. And for us, it was pretty straightforward. We had to let the CEO talk, stay quiet, and when we were asked to say anything, speak up. But otherwise, just be present and be there as a team. So we really sold the team as opposed to selling the product per se. And for the first time in my life, I saw what pitching to VC was, and doing it in a way that was very new to me. I heard stories about it. I heard friends talking about it. I read books about it. But this was hot, and being in the room doing it was fun. 2 weeks it took us. We did this for 2 weeks. And this means during the day, you go, as I said, first to a coffee shop to meet each other. You go to the VC. You actually get the presentation done. Then you get out, go back to a coffee shop, go to the next one. And you do this for 2 weeks, all day long. And you don't know if they like it or not. You don't know. They don't really give you much feedback. But after 2 weeks, you get a sense because they start talking to each other. Our CEO was actually pretty smart. He was able to understand which VC to go first, so to create some buzz, some noise, and get the other ones to be jealous about it and talk about it on the golf course and say, "Oh, did you hear about that company?" "No, I didn't." "What? You didn't hear about that? So you should definitely." So we were able to open doors with that approach. So nothing from me for opening doors. This was just our CEO able to do an excellent job into getting access to the VC.
Well, I think you're underselling yourself as a storyteller here. I mean, you may have learned from Andrew, but this is an incredible,
learned from the
this is an
best, maybe.
incredible story. I mean, I'll let you, of course, continue, but just maybe two things I wanna park quickly. One is just a funny side story. That I met Andrew in 2014, so just before when I was still in the Valley, because small world, right? His father is a professor at Stanford, and he was my postdoc advisor, and I would just happen to be in the area, and I was sort of embarking on also various adventures in the startup world, and I met with his father. And he said, "Oh, you should talk to my son. He's into computers." And so he hooked us up, and yeah, I remember fondly. He's obviously a brilliant guy indeed. And the second thing I just want to put down, but maybe for later the discussion, you make it sound like, I mean, this is sort of the quintessential Silicon Valley story. I mean, you go in, you pitch something, you know, the right people, 15 minutes, and you walk out with basically. And so I'll let you, of course, finish the story, but I want to discuss with you why you think that's possible, and if the same thing would have been possible in Europe, for example, and if not, which might be the answer, why not? But that's just something, right? We can discuss later.
So indeed, Andrew is a very good storyteller. He knows how to take an idea, a message you want to get through, and shape it in a story form that speaks to the audience, and he's good at that. We were able to open doors because he knew a few VCs, but also because who we were. We had worked together before. Andrew was not a first-time CEO. He had been CEO and co-founder of C-Micro. He founded C-Micro with Gary Lauterbach, who is our CTO, or was our CTO and co-founder. So the two of them had already funded and brought a company from ground up to being sold to AMD a couple of years later. Myself, Sean Lee, and Michael James, the other three co-founders, were part of that C-Micro adventure as very early employees. Actually, I was not even an employee. I was actually a consultant for them for a long time. I worked on the chassis, on the system, and designing and architecting their system. Sean Lee was on the ASIC side doing the chip design, and Michael joined a tiny bit later, but was on the software development side and also part of the chip design. And because we were who we were able to open doors, get listened to, and seriously listened to. I remember the first slide was not about what we wanted to do. It was about us, who we were, so that the audience know who they're talking to, who's pitching them, what's their history, what they've done. And I think having done something together before, being a success or not doesn't matter. Just being together, having done something, knowing that we could work together made us stronger. And also because we were different, not the same domain, not the same expertise, very complementary. And because we wanted to make a dent in a computer world where it's not sufficient to make a chip, it's not sufficient to make a piece of software, it's not sufficient to make a chassis, but it is the combination of all those as a vertically integrated approach that allows you to really have a success as opposed to a mild success on a small chip that we were able to get listened to. Remember, there was not much fun for funding a hardware startup, and this was a hardware startup. And because of that, we wanted to do something big, and not just a big chip, but a big system, a big product. And so we had to be supporting that idea with the team. And the team at that time was just 5 of us. So I agree, it's not as simple as just having an idea in school, for example, and going out pitching to a VC and getting funding. We actually saw many of people trying to do that when we were pitching, because we were waiting in the lobby or waiting in the waiting room, and people were shitting their pants, as we say, right? They were really scared and freaking out because it's very stressful to do that. And we saw how those people were pitching in a way, and the type of money they were asking. They were asking maybe for $1 or $2 million for some of the ideas, and many VCs don't even care about that. They want something bigger. They don't want to spend time or invest in something small. They want to invest in something big, and very often in big software solutions. And in our case, was big in a hardware-based product, and so we had to go big. So we raised for the first round, I believe, 27 or 28 million, Series A. We went from nothing to Series A. Because we had to make a chip. So we had to secure what it takes to tape out the first chip.
Mm-hmm.
I think the size made a difference.
The size of the chip.
The size, not on the physical chip, but the size of the investment that has to be done.
I see.
Appealed to the VC. If you're too small, they don't care. If you're too big, they don't care. You just in the middle was okay.
But was the fact that you were going to build the largest chip in the world part of the narrative that you pitched at the time, or
Absolutely
not?
For context, we at Cerebras make the largest chip in the world, but we didn't start there. We knew that we had to make a big chip, but we didn't pitch it as such. We knew it has to be very, very, very fast, much faster than the existing one. So we went with 1,000 times faster than the present best-in-class GPU offering. That was the pitch. We didn't say how, we didn't say what, we didn't say how it would be packaged, none of that. It was just, we would make the largest chip, and we know how. We have an idea how to do it, and we want to do it this way. But we didn't explain anything on the how. It was the what. And we didn't say it was a chip. We say it was a product that outperforms a present system. We didn't say we want to make a chip. We said we want to make a product. And the product was not just one chip. It was the entire packaged solution with its software abstraction and the whole thing.
I see. And you said before that when you first got together, you were discussing about recent developments in machine learning. It's interesting. The timing is interesting because that's also when you show sort of to the general public when deep learning really takes off, and when also big industry investments take off, and when people start to realize, oh, there's something there that seems to be working extremely well. That's just a few years before, right? The first AlexNet and then ImageNet and so on coming out. That's around that time. So was that still too academic, or was that already part of the narrative for the pitch that you pitched this as a machine learning and as an AI chip, or was that not yet quite as on the agenda as it would be today?
We did not have to convince that AI was going to be a big market. There were already software companies being funded to create the application level based on AI model, deep learning model. And therefore, we don't have to pitch for that. We had to pitch for a solution that the industry had a problem with. The problem being the speed at which these models were trained was just unbelievably slow. And so we saw a trend, and we were only in the pitching exposing the trend, but didn't have to justify it other than showing that trend. Large language models were the way to go. There were larger and larger models being used for creating a small application at the time, but we knew that the overall business landscape was going to be adjusted or changed or enhanced, amplified by this wave of opportunities. So yeah, we rode a wave in a way of investments that were done on software startups. And we said, no, we not only we cannot perform what these startups are saying, that they can improve the performance of a GPU computation by 2 or 3% or 10%, some 20%. No, we are coming with 1,000x faster, not 20%. So the pitching that the other companies were mostly doing when they wanted to optimize a workload was, we're going to change the software. We're going to change the way we use CUDA. We're going to change the way we optimize the memory transfers or storage transfers or network transfers, and we're going to optimize what the GPU does without changing the GPU. And the speed up factors were substantial for what they wanted, but less than an order of magnitude. They were at the best 2x the speed. And we come in and we say, no, you're 2x here, it's peanuts. We're going to give you 1,000x. So suddenly the work that the other guys have done pitching the story about the market helped us because, well, we already had that done for us. And we only needed to prove that the team was capable of doing it.
And then if you now look back at these years, and now in particular also, of course, the years, the past few years and the recent developments, I mean, if you would go back, would you, I mean, I don't want to ask, did you see that to some extent? Nobody really, I guess, saw it concretely, but were you still surprised by the enormous speed and scaling up process?
Very early on, we had interactions and partnerships with OpenAI. We actually even had some employees of OpenAI worked in our offices, work on our machines, and we collaborated on various topics. We had discussion early on with Microsoft on our project and what we wanted to do. We also had discussion with Elon Musk. Musk came to our office. I shook his hand and showed our systems early on. And we knew before the entire public was really, or the planet was aware of ChatGPT and AI in its current rendition. So we knew how this was evolving and the type of investment that were done it was very hard to talk to our friends about it because no one knew really what we were talking about. Even if we could speak about some aspects that were not too confidential, the public in a traditional conversation would not even understand what we were talking about. So it was not a surprise. What surprised us was the amplitude of the reaction. That, yes, that ChatGPT was coming, we knew. That what it could do, we knew. What the potential of derivative from that type of large language model were about, we knew. We were anticipating an explosion of interest, but not to that extent. What we saw was a realization that went at first with people realizing what it was, and after some time realizing the industry realized what, from a business standpoint, what they could do. And that triggered in the company a phenomenon boost of interest in our products. Not only ours, in general, anything that could accelerate compute was in extremely high demand, especially the compute for neural networks, which is a little special compared to traditional high-performance computing in the sense that you don't need as high precision, and it's mostly matrix multiplications. And in the context of machine learning, you can even afford sparse matrix multiplications where you have many, many zeros within a matrix, and you can optimize that out with a different architecture. So we were aware, surprised by the amplitude. I think everyone has been surprised by the amplitude.
So you went from trying to convince people that investing in hardware is a good idea, and it being challenging, though in your case, obviously you did it successfully, to a geopolitical discussion of compute-poor nations and compute-rich nations within less than a decade.
Yeah, it's a phenomenal adventure in that sense. That goes from an idea somewhat in a garage and the original state very nimble in a way, to something that suddenly you realize is being embraced worldwide. And you realize also that the demand is growing tremendously beyond imagination. And luckily, we were ready at the right time. So a lot of luck in what we've done as well. Right time, right partners with whom we worked with. We were lucky in our ability to actually make the chip, package the chip, get a system up, and get the software for it. Remember, I spent 9 months at the very beginning trying to find out how we would make this chip, what was the best architecture and process to make such a large chip. Initially, we didn't make a wafer scale design. We made it a reconstructed chiplet-like multi-chip module. But we found out that we could not get the bandwidth and we could not get the yield that we needed. So we had to make a jump and decide to go and monolithically design this, basically use an entire wafer and not cut it, test it, and yield it, which means that an entire wafer can never yield. You always have defects on it. So we architected it such that we could afford to have defects, mask them out, and map it again or program it such that software can see a pristine wafer. All that took us years because not only the design of the chip was difficult, we had to convince TSMC to work with us to enable communications between what we call them reticles. When you make a chip, what you do is you don't make a single large chip like this. You actually make chips that are at most the size of what can be imaged by lithographic process. And this has a limit on size, and you step and repeat that same image over the entire surface of the wafer. And we had to convince them that we could get communication between these patterned reticles. So we had to negotiate with them and convince them this was something they should do with us, even though
TSMC is the Taiwanese manufacturer, correct?
TSMC is the silicon foundry in Taiwan that produces most of the high-end chips in the world. Now, to convince them, we had no volume. So it was not a financial incentive for them to work with us. It was more a strategic one. They currently serve the largest manufacturer of GPU, and at the time as well. And for them, if that manufacturer, or I would say this GPU manufacturer has some trouble, or if the market in which they're planning has some trouble, then they are in even more trouble because they have very large and very reduced number of customers of that kind. So if an NVIDIA does not go well, then TSMC has a direct impact on their production flow. So instead of being centered on very few number of customers, very large, they wanted to diversify a little bit and bet on newcomers. So that's how we got the opportunity to work with them. But there too, opening the door to TSMC is not something that is easily done. You can apply on the website. You're not going to have a lot of luck doing that. We were lucky to have the right VC partners to do that introduction. So they opened doors for us that we would otherwise not have been able to do. Can you do that with VCs in Europe? Maybe. I'm not sure. This is one of the questions you ask. Could we have done that in Europe? Well, VC helps us a lot, a ton. They are really extremely helpful to get you going because it's in their interest to make you successful. So they open doors for you. They have a Rolodex that gets you access to anyone in the world. And in this particular case, we needed access to the very top at TSMC so that the soldiers at TSMC, we are all soldiers of someone, could actually pay attention to who we were and offer us at least the opportunity to talk to them and try to convince them.
So VCs is not just about money, it's also about value.
Or you should be careful when you choose your VC.
Yeah.
Don't think they only choose you. You choose that.
Mm-hmm.
And make sure you choose the one that can help you the most.
Mm-hmm.
It's essential.
Yeah.
And not just to open doors to someone like TSMC, but also to open doors to talent. They are the one that are going to find the best talent for your company.
And so today your flagship chip is very large.
Yes, it's a 300 millimeter wafer, which is the largest silicon wafer produced today, which we cut square. So a single square out of it, which is about 215 millimeter by 215 millimeter on a side. And we don't cut it further. We keep it full. We test it and we package it. The packaging, we had to invent packaging. No one packages a chip like this. Actually, when we started to tell people that we wanted to package this, everyone said, no. I heard no for 3 years continuously. And we had to invent the way to package it. I had no expertise in packaging before of a chip. No one had in our company. And so we had to ask many questions. We had to ask experts. We went to academia to understand what they did, why people did it this way, why is it done that way, why not this way. And we learned as fast as we could. And then we decided, okay, it's going to be a wafer scale. Let's do it with the TSMC. They agreed. Let's make it, and then let's package it. And for 3 years, I failed packaging it. So imagine going to your board every quarter or every 2 months and telling them, sorry, I failed again, and I need another 2 months to keep going, and do that for 3 years in a row. And keeping confidence in the relationship was not an easy thing to do. Ended up succeeding, and we solved that problem. Packaging it was possible. Now you need to produce it in decent volume. Okay, that was another step to get through. Not easy to scale and to produce it beyond just a prototype. And that once you've produced it, then but how do you use it? So a lot of software had to be engineered and produced to abstract the complexity of such a piece of hardware to application software. And that took us a long time. The software piece is the most difficult part. If you think packaging is hard, writing software to abstract complexity is also extremely hard.
Are you, I mean, now, again, I'm always fascinated by the fact that one speaks about these things, obviously in retrospect, and especially normally under a consideration where everything in the end checked out. But as you just described, I mean, you're going to this board for 3 years. And obviously in the end you succeeded, but were there ever moments where you yourself thought, actually, this might just not work, or I'm going to fail?
Every morning,
Every morning.
every morning, every evening, every time of the day is when you think that, oh man, this is not going to work. And so
Keep going.
so two things keeps you going. One is your co-founders, co-workers, are the people that you can refer to and are going to make you stand up again and keep going. And also, on the other hand, as a leader, you also need to convince many other people. So you have to be convinced, even though at times you might doubt yourself, but you actually go through the job of convincing others all the time. You had to convince the founders first. You have to convince the VC to do it. You have to convince the first employees to join. The next employee, the next director or leader or manager, you need to convince them. And then you need to convince all the suppliers to work with you, because they all say no. When they understand what you're doing, they just laugh at you and kick you out the door, or don't stay for more than 2 minutes in your room because they realize how crazy you are and they don't want to work with you. So you have to convince, and you get good at it, meaning not convincing, but actually doing the convincing. You get good at it and you can do it again, and it becomes a habit, which is actually spreading. It's contagious. When we hire someone, the first 2 weeks, they're super excited. After 2 weeks, they realize that what the heck they did. In which type of nightmare they just ended up. Why did they move that cushy job that they had at that large company that paid more than us? Why did they come? They feel they're not going to succeed. They're going to fail. So we actually allow them to fail. We allow them to not feel comfortable, and then help them stand up again and do it again, go over it, and get successful over time, not the first time. Fail fast. I always tell many people, just go fast, fail fast, just learn faster, and then you get better at it, and over time you're going to have some success. That's what we did over and over and over again. And I tell you, we failed so many times. We made so many mosaic of our wafers. They were completely broken. How many times we built something and all the way to the very end, and suddenly, everything was wrong and crashed and cracked, and go back to the drawing board and start again.
And how do you, I mean, I think that's an extremely interesting dynamic. You want to try many things. You want to fail fast. There's always this interesting balance, right? Where people say, okay, you should quickly realize when something is not working. At the same time, that's 50% of the advice you get. 50% of the advice you get is keep at it, right? Don't give up. And like how to find that optimum, and realizing that you're truly on the wrong path and you need to go somewhere else.
It's obvious after the fact. But when you're in the middle of it, it's always both painful to give up and painful to continue. You're right. It's very often difficult to judge. I guess you get better at it. You're not always right. I prefer to be 100% of the time, 80% right. Right? That 80% of the time, 100% right. It's extremely important not to seek exactness. and allow for failures that are not complete monster failures, but also try and errors that allows you to learn something. You learn more in the journey than you learn in the outcome. And so that's what you do. You actually start to segment the task such that you can do small experiments to learn. And at some point you realize, okay, those small experiments are not giving me enough information. You're not learning enough. So you go to a bigger one or you change. But you don't change like, we didn't change to go from building another architecture for computing neural networks to, I don't know, doing a smartphone. We didn't change domain completely. Yeah. The goal, the vision was identical. It's the how to get there that slightly got adjusted. And I say slightly because we cannot just change the fab or say we go with TSMC one day and then go with another foundry another day. We didn't do that. Once you commit to one, you go all the way through. Even so, there were huge challenges to actually make this wafer scale engine producible. And you keep at it. While you are in it, you make failures. And it is those small failures that you need to keep going. Don't give up. But if the market had told us that this was not the right path, for example, when we came out of stealth mode and we had the first serious customer looking at what we do, and if the feedback at that time was, go back to the drawing board, this is not quite interesting, then yeah, do go back to the drawing board and change. Don't wait until you find the customer that tells you yes. Don't wait too long, at least. Search a little bit, but don't wait too long. The market feedback is the one that should really make you change. Or if you are in a direction, for example, in the packaging, I had a supplier that was giving us one component in particular that was causing trouble. Kept trying to improve it. For 2 years, we tried. In the end, we decided to have someone dedicated to search for another supplier, to search for another solution there. And we had to change because that was too long. So we gave up on the supplier, but not on the idea, not on the vision we had for that interconnect. It was an interconnection solution, and we designed that interconnection with that other supplier in a way that was very fruitful. So if we didn't have gone with the first one, we probably wouldn't have been able to do such a good job after it. So, and it's always easy to say so afterwards, but and I don't know which other opportunities we missed along the way, but at least we got it done after all.
Mm-hmm. So knowing where to go is almost the most important thing. Once you have that, the path, you'll figure something out, but at least you know where you're going. Another thing that you mentioned a couple of times now is the importance of your original team. And obviously, in your case, you had a fantastic team on all these dimensions. How does one get a good team to begin with? Where does one find the right people to work with?
In school, as early as possible is when you actually create relationships, you create memories, you create adventures with people. And that's when you create what it takes later to put things together. You don't know at the time. But it ended up not only allowing us, the 5 of us, to get together again, but also to hire the next level of people in the company. We hired who we knew. We didn't go with the headhunters, or we didn't post job offerings. The first 30, 35, 40 people were all people we knew. So that's when either as a founder, you find other potential entrepreneurs to found a company, or when you have founders that know you, that you can join as an employee, early stage employee, and you can go through such an adventure with them, it is likely that the next adventure they're going to do, or if you have an opportunity to do your own, you might benefit from that relationship. So start as early as possible to create the ingredients for it. Now, how do you actually make the meal with those ingredients? When? That's a different story. And very often it's a number of, I would say, it's a number of things that you don't have really control over. They just happen. And if you can see them, if you can observe and see when it happens, it's often easier than when you want to make it happen. We didn't start because we had to. We didn't start because we were in a hurry to get rich, or because we were in a hurry to get successful. No, we started because we had time, and we took the time to really think about it and not stress about it. And I had many such conversations with others before. I failed making a startup many times. We don't talk about those because, well, they didn't go very well and they didn't go very far. So, well, we often forget about that try, and if it doesn't work, try again.
The outside forgets, but you probably don't.
There are many experiences in that sense that you can then refer to. It's not your first time trial. Yeah. When we started the company, I thought, well, I would be very happy if it lasted 2 years. We're 8 years in, and I'm still super happy. So you don't know. You need to realize when you feel that the mayonnaise is taking. When people start to feel good about it, excited about it, and not just within the team, but the team surrounding you understands what you're doing, what you're chasing, and feels confident that you can succeed. Our VCs were actually very confident we had the opportunity to succeed. They would not have invested in us.
That's a good message also to potential founders out there that might still be overly worried about the what if this doesn't work question. So your answer is basically nobody will care. Just continue until you find the thing that succeeds, and then anyways, that's what everyone will talk about, and you yourself.
Correct. The fear of failure is a huge impediment. You should have your eyes on the ball, focused on you're going to make this a success. And yeah, 9 out of 10, you're likely to fail. So what? You failed when? At the beginning, in the middle, towards late stage, just before you got really successful? Did your product got sold or not? At any stage, you might be stopped in your path. Doesn't mean that it is a total failure. It's actually a success because you learned something and you were able to accumulate some experience with this that's going to be helpful the next time. And so we hired many people that you could consider have failed, but they're extremely successful, in fact. And I don't feel that I've been successful along the way. I've made many failures per se, but they were the one that allowed me to get where I am. So no, keep doing it. And an entrepreneur, you might fail for reasons that are completely outside of your control. Completely. That's the best way to fail. Well, you can. It was not your fault that you didn't succeed or was hard. Maybe next time you can see that better. Maybe next time you're equipped with some tools that allows you some visibility. Now you have contacts. You have people that can help you, that can coach you, can open doors. Let's just go do it. That's the best I could think of. True, in Silicon Valley, you have maybe an advantage is that you have a lot of opportunity. You don't have to move your entire family. You don't have to change language or you don't have to change culture so much when you have when you lose a job or you lose a venture and you need to start over again. You might have to move a little bit, but it's not as impactful as you might think. At least at the first level, you might think it's not as impactful. I think in Europe, you might have a different regional network that might force you to move. But think about it, it's not that big of a deal. And if you've been reasonably good at your job, you will find another solution, where you will find another job. Maybe not as cushy and as good as the one you just had, but the one after the one you have is probably going to be far better. So be confident.
So that's interesting also, and that's maybe a good segue to move the discussion away from the company to you as a person, because what you just explained, with which I agree 100%, is what one would classically expect from someone living or breathing the Silicon Valley spirit, or perhaps a general US spirit. And it's, of course, what we often hear from a European perspective, that that's the kind of attitude that's so lacking in Europe. Do you think that's true? I mean, you're obviously a good example, born and raised in Switzerland and educated here, but was that your attitude from the beginning, or is that a cultural import to you from the US?
I don't have the experience of raising money and having I would say, being an entrepreneur in Europe. I have no idea for that. But I definitely feel a difference. I've seen people coming from Europe to raise funds in the US. And I've seen other entrepreneurs in the US trying to raise funds, and I see a difference there. Maybe in the size of the ambition, and the confidence that they might have. In the US, you might be overly confident, and in Europe, you might be completely underselling yourself, and undercutting your opportunities. I've seen that especially when I helped a few people trying to get into VC firms. I can see it. On the other hand, living in the Bay Area for so long has a big impact on you. It shapes you. I guess if you stayed in Bassin Lémanique, you would also be shaped by the region and the culture. They're all good, but for some aspects of entrepreneurship, I think they have an impact. I've seen myself often, even after so many years there, still having this underselling myself in some areas. Just I don't feel comfortable with it. As an engineer, sometimes you just introvert and you don't do it, even though you're trying to learn from the best that do it. It sticks with you. And so if you stay here for so long, you might stick with a different cultural behavior, or way to express, way to communicate, way to understand others, way to perceive from others, and overall it gets a mix of attitudes and reactions that prevents you from getting the best out of your idea or the best out of a venture you're trying to build and grow. I don't know. Maybe I should try in Switzerland to see the difference. What I've seen is diverse, but also always coming from Silicon Valley. I haven't tried the East Coast, for example, on the in the US, which might be slightly different too. Definitely the concentration of VCs that are ready to put 10, 20 million from the get-go into a small team that has nothing is pretty impressive. And so the type of money available in Silicon Valley from that perspective is helpful to the entrepreneur. There are many entrepreneurs that got really rich and they don't know what to do with their money, and though they became VC and they actually take risks that no one else would want to take. That's somewhat easy money for entrepreneur again, and it feeds itself. If you come in Switzerland, I talked to a few entrepreneurs and they said, "Oh, I cannot get funding, and no one is helping. I don't have a good network of relationship. I'm all alone. I feel not very supported." There is a better network now. This was 20, 25 years ago. There is a much better network now. I know it's much better. But when you need big money, it's still challenging. And the doors for those big money are maybe a little harder to open. So you might be able to do something reasonably, a pretty successful small venture, but if you want to go big, it might be a little harder. But I would not stop there. Try to get to that size already, and then we'll see. You'll find a way to get beyond that.
Well, we're now hearing some encouraging stories and signals, at least out of Europe, I would say. I mean, it's still somewhat patchy, but I look at France, for example, as a good example of what they're trying to achieve there with Station F and in Paris and companies like Mistral, where of course you can still argue, well, still the really big checks typically have a U.S. postal address stamped on them, but nevertheless they're building the company here. And then of course they will eventually, anyways, certainly have large business in the U.S. as well. But I think it's great to see early signs that this seems to become also more possible here. And I think especially in the beginning, it's so important for the reasons that you mentioned, because once they exit or IPO or whatever, then they have the cash and the experience and the network to help the next generation. And that's, of course, as you say, exactly what happened in Silicon Valley, which we're still a bit suffering from not having, or from having a late start here. But if you would be asked to imagine that the Cerebras story would have played out in Europe, and imagined an ecosystem, like what in your view is the most urgent thing to do? And if we want to, in 10 years, have the same conversation with someone in maybe a similar space and say, yeah, we got together in Barcelona or in Paris or in London or in Lausanne or wherever, what would you say is the most important thing we need to do now to make that happen?
It's already happening in a way. You have a lot of help from different entity, government and schools, to put together an environment that allows startups to be created. What I have not seen as much, maybe I'm not seeing it, maybe I'm not looking for it, is more the support that the community of investment can bring. Have the example in our case where we had VCs that not all had good background in hardware companies. One of them, Eclipse in particular, had Pierre Lamont as one of the managing founders of Eclipse, able to really guide us and act as a reference for what we were doing. Someone who understands the field, understand the history of startup in that field, and allows us to maneuver the company, direct the company in the proper directions as some challenges were arising, and guide us. Here's the same thing, I guess. You need to have the investors that can help you guide, and not just people that place money in the company, but can actually provide the tremendous guidance that entrepreneur needs. I was not aware of that before starting Cerebras. I was not realizing how important those investors are. And as for sure, as the company grows and becomes bigger, then it's more financial investors that come and become the steering entities in the company. But early stage, that's where you have most of the impact. And it's not necessarily the amount of money, it's the experience into getting to that money and to getting the company to do good for the market that they're tackling.
For which you need really the domain know-how.
So one way to get that is not just by having nice buildings that gives you access to a secretary office that takes care of the phone calls or the legal burden of a small startup. And those are all super simple things, actually. The tough part is how do you actually help a CEO and a leadership team go in the right direction and structure the company in a way that is more successful for the company. And that's where you get the most help. I haven't heard that from some of the colleagues that I have in Europe that are entrepreneur. It's a little tougher.
Is there also a cultural impediment? But what I mean by that is, I think in the US and in Silicon Valley in particular, but in the US, perhaps also through its history, right? We must nevertheless realize that ultimately the vast majority of the people living in the US are in one way or another descendants from people who left safe shores and just went into somewhat the unknown. So in my time in the US, I always felt that sense that being there first is something very important, right? And something that's valued in novelty in itself. Whereas in Europe, there's that is less of a thing to be valued. It's much more perhaps the quality, and in fact, people are often, I mean, it's a bit stereotypical, but still often critical for a long time. And then all of a sudden, they get on board and they try to do the quality. But by that time, many of those so important early stage dynamics for building these networks and people building the experience and the expertise has passed.
Yes, you raise a good point about being there first or appeal of the new and go there as be there first and be there fast. It comes from the money too. It's driven by the type of money. In Silicon Valley in particular, to the extreme, you have a lot of new money. It's money that has been made over the last couple of decades only. And that money has been made fast, quick, and also spent fast and quick. And so it's small newcomers that are wealthy, but they're not gazillionaires. They're not the equivalent of the old wealth that is in Europe, for example, where it's mostly family-owned. Very, very wealthy families in Europe have most of the wealth, and they're keeping it for safeguarding it, for maintaining it over a long term. And they had that for centuries. So it's old money versus new money. The new money being more agile, more movable, more spendable, more dynamic in a way, versus the old money that is more as an investment for long term, very cautionary spending on it when it's secure, sure. And I think it has a big impact on the overall way we can support entrepreneurship and how entrepreneurship is de facto supported in those two regions. It's very easy to get money to start. It's harder to continue to get more, to continue to prosper in Silicon Valley. That's hard. But getting it at first, the starting is easier. While in Europe, even starting is sometimes tough. And it's made tough because they start too small. Like, oh, I need 100K to start something. Like, guys, 100K? Really? For our year? What if your competitor was able to invest 500K? Would that make a difference? Oh yeah, it would make. So go with 500 right from the get-go. If someone else can go faster than you, and this is the fast, go fast, right? If someone else could go faster than you, then ask for the money you need to go faster, because if they could, they will. If they see an opportunity that makes sense to chase, they will outperform you because they will be able to invest slightly more and go faster than you. That type of reasoning is very different, I think, between the two continents.
Mhm.
Not everywhere. I'm generalizing. Obviously, there are exceptions, right? But it has an impact on the culture, I'm pretty sure.
So if we take that now to AI, I think there that plays out. I mean, it's a prime example, right, of that playing out. I mean, I guess a couple of years ago, perhaps even as late as early 23, you could probably still try to build a sort of foundational company, sort of trying to compete with OpenAI. But already after that, you were too late. Now, obviously, there's many great things. It's an explosion, a Cambrian explosion now of opportunities in AI. But it's always impressive just how quickly space is taken. And in your case, with hardware, I guess for all the reasons that you described, it actually does take a little longer because it is hardware. It is, as the word also implies, it is hard in many ways, difficult. Whereas, and even I guess the early internet startups of their time, I mean, even that took, of course, a certain amount of time because you had to first build the whole infrastructure of the internet and people had to get also used to it. And whereas now with AI, that's all here. I mean, still limited by compute, but you have the whole infrastructure. So if you can launch something like ChatGPT and then literally overnight, you can potentially have 100 million customers. And I think that dynamic is still not properly understood, except in sort of the places like Silicon Valley. And it somewhat gets harder to understand because it becomes so detached also from our personal reality. I kind of understand how somebody quickly gets 10,000 customers. That's something I can somehow compute still in my brain. Already difficult, but right, I can imagine a big hall of people, 10,000 people, but 100 million, I cannot. I understand it mathematically, but I cannot.
The dynamics, the recent dynamics in that space are unprecedented. It's the first time that an industry has this type of evolution in such a short amount of time. And it's like a tsunami. You hear it in the far, and suddenly it hits you, and it hits you big. If you're not prepared, you get completely submerged. If you are prepared, you can ride the wave and probably survive. And if you knew how to ride a wave before that, you can probably have a good time surfing that wave. It takes time. Even OpenAI, we worked with them at the very beginning. It took them some time to get there. So it's not overnight. And if you look at the amount of investment they got to get started, was pretty darn big. Elon Musk didn't start small. He started big with them. And so they were able, from the get-go, to start with the team that was very, very smart and very large, a critical mass to get extreme development done. It's not 4 guys in a garage for a year. This is a large team of world-class programmers that were eccentric in a way, that were put together to actually develop this. And they succeeded because they had that critical mass. So it takes time, and you need the critical mass. So you don't see it now because you only see the product and how that product has been embraced. And they're also victim of their own success in some ways. It's not all rosy. Nevertheless, it got attention to other very large players, Microsoft, who has access to that number of customers and who knows how to structure things, structure the business to be able to access, to make an impact, and to leverage that from a business standpoint. Or if they don't have a return on investment right away, they can foresee what this could look like. They can project themselves and put the right roadmap or draw the right roads on which to ride then to get there. Mm-hmm. If you want to compete against them, you better compete on something slightly different, complementary, slightly different, where you have a better opportunity. The first comer gets it almost all. And then if you have to come second, you better come second with another value proposition, something else. Sometimes it's just cost, it's cheaper, and people just shift to you. Sometimes it's a different technology. Sometimes it's something slightly different, because you go head to head, you better pile up the investments to compete with what they are getting. And if you think you can do it in a year, and if you could get twice as much money and do it in 6 months, think again, because maybe you can get 4 times the money and in 3 months it's done, and maybe that's the way to do it.
Yeah. Yeah, I mean, the investment needed, of course, now for these models is through the roof. I mean, I think we're just months away before somebody announces a model that costs 1 billion just in training, probably, and then the next order of magnitude is probably also only one year or 2 years max away. Enormous capital intensive, of course.
Yeah. So what is surprising there is how quickly the large players, the one that have a lot of money, not necessarily in tech, saw this coming and decided to bet on it, because they haven't gotten all the returns yet. They've gotten enough returns to validate the prediction model that they have about the success that this has to be and will be for them. So the amount of investments is just unbelievable. I mean, I think Switzerland invested how many billions to create the tunnel under the Alps? I forgot the number.
Oh, I also forgot the number.
A couple, right?
Quite a few.
Couple of billions. I don't know if it was, but it was less than 100 billion, was it?
Yeah. I think it was two-digit billion.
2 digits, right?
But I think lower 2-digit. But I'm off.
Okay, so and now you compare with what is being invested in AI around the world by big pockets. They're going to make equivalent of tunnels everywhere. And this is not built in how many years it was built?
Oh, the tunnel? Yeah. It takes a long time building tunnels.
This is built in like a couple of years, like a handful of years at most. Yeah. That gives you a size idea of the dynamic. Not only it is much bigger than this type of huge entrepreneurship program that we had in Switzerland for this big railroad or tunnels or, infrastructure project. And suddenly it is compute infrastructure projects at the scale that is multiple orders of magnitude bigger than that. And so it starts to become comparable to some of the infrastructures we've seen deployed for shipping or for energy. And obviously, for many years, this was completely even all the tech companies together were a fraction of the business trade, right? But this starts to now look very comparable in some respect, especially in growth. It's just phenomenal.
That's an interesting angle, by the way, because there is this observation that this type of, moonshot project used to be government funded, right? When people decided we should get on the moon, it was clear there was a government agency going to do that. When you decide to build a bomb, fine, right? You're talking about violence. Obviously, the government has a monopoly on violence. But still, there were many of these things where it's such a big shot and a long shot that, of course, the government has to do it. Whereas now it's very different. And in fact, I a couple of years ago read sort of the founding documents of OpenAI, where they actually explain that fairly, dryly, and say, well, okay, we want to build superhuman intelligence, and in any period before that, that would have been a project of the government, but not now anymore, and we don't want to sit around and wait for history to change, so we are going to do it ourselves. And so it's interesting that in a place like Switzerland, for example, we can build these amazing tunnels as government infrastructure projects that are well done and done on time and budget, which is not something necessarily the US, for example, can claim these days. But then we don't have that similar, that sort of, not that a tunnel is a moonshot, but that kind of capital investment and vision in the private market here.
Because it's most likely this is most likely due to the speed at which this is going. People need to realize, need to understand, and to act accordingly in matters of years as opposed to decades. And this is probably why we are taken at a surprise. Europe in general has been somewhat fearing AI more than other areas of the world where they're more bullish about it. And that has caused even more so a like wait and see type of attitude, or be cautious on it. Not that I would go further, forward without guardrails. That's not what I'm advising for. But the fact that we are thinking about it a little more makes it even more of a sharp contrast.
I find that surprising, and I think you told me before you observed that as well in your discussions. It seems like, especially also during COVID, right? There was this big realization that, okay, wow, we really have some issues when it comes to technological delay and sort of the European drama about having really missed out on the technology, the digital revolution in the past 30 years. And slowly, right, it's really arriving everywhere, Draghi report and so on. You can really sense increasingly a bit of an angst about having missed the boat big on this one, which I think was pretty obvious if you look just a bit at tech for some time. But that now there isn't this strong sense of, okay, we missed that revolution, right, with the World Wide Web and everything that happened after, but we're not going to miss this AI revolution, right? You would normally think now is really the time for people here to say, okay, this one, right, we're going to lead, but it doesn't seem to be happening.
No, I asked the questions around me when I was in Switzerland. Where did you place? Where is the CERN of AI? Where is the equivalent multinational project that brings scientists and even industry together to create something for the good of that industry, for the good of the people that are in that area? It's not there. There are a couple of centers that are doing it, but a little bit on their own. And the type of infrastructure that they can afford, both in people and in equipment, is scaled to their size. And when you see some of the investment that are done in the Middle East or in Far Asia, wow, the gap is increasing there. There is a gap that's actually increasing, and so not only it's a miss, but it's a gap that is getting wider and wider. It's frightening in a way, because you feel where is this gonna go? You can see the development that's done in UAE, for example, or in Saudi Arabia, or even in India. Not to mention China, obviously, in research in AI and application related to AI, on developing it in a way that is, constructive, where you understand where you can use it for good, where you should not use it for, because it could be evil or bad or damaging. But just knowing about it and working for it, obviously, a lot of research, a lot of product will come out of those efforts that we see around the world. And a lot of application and business related to those applications will come back to those countries that are actually investing in it. I see some of that being done in Europe, but at least through my own little lens of infrastructure supplier per se, we don't see it as much.
And you brought up the geopolitical dimension. How do you think about this? I mean, you are obviously already, I guess, just through your job in the chip business, you're quite exposed to a certain extent, I guess one could say, to some of these dynamics already. But from an AI perspective, what's your thinking there? I mean, there are people that argue that this thing is developing so fast that so maybe taking a step back, the argument is always you have conflicts, obviously, otherwise, right, we wouldn't be discussing. I mean, if everybody's at peace, then great. But the issue is we have always conflicts. And in a conflict, who usually wins is the one with the bigger technology advance. And the larger the delta between technology, the more clear the outcome is going to be. And there's now many people arguing that this technology is now advancing so fast that within a very short period of time, you can reach technology deltas between the ones who advance and the ones who don't, that are just could be matchmaking, right? That are similar to what used to take 30, 50 or even more years. That could potentially happen now in years, or once you go closer to AGI, potentially even in months. Do you think that's crazy talk, realistic, something to be worried about?
Should not be underestimated. You could see people on both extreme of the spectrum be very bullish, fantasizing about many things, and on the other end, people that say we should not do anything and we should put a halt to everything until we figure out what the heck is going on. None of those are good. A better approach in my mind is to be aware and actually act towards a better understanding, because it's the understanding that's missing here. It's going so fast that people don't realize. They don't understand the relationship between the type of investment in infrastructure that can give you access to power, to influence, and resulting economic growth behind it. Technology is going to help in this sense. If you have an advanced AI capability, an understanding of it, you can shape it for your own good. If you don't have it, you're going to be just submissive and you're going to just use whatever is done elsewhere as a user, as a consumer of it, but you will not be able to shape it. There is an example that I've seen where some large language models are trained with medical data that is available from some companies. Turns out that the good out of those model treatments, recommendation for treatments, uh, uh, also a diagnosis and pinpointing if there is a risk of a given disease, or a recommendation for a medication or formulation for a medication, start to be tailored to the data that you used. If you did not use the data of a given population, you will not get the proper treatment for that population. You will not get the information for that. It's like not having the voting rights into something that gives you good. Mm-hmm. If you don't have your data actually participating in some of those large projects, you will not be represented in the products that are made as a service to the society. If as a country, you limit yourself to only develop what you can afford within, then you are not going to be able to have all the products that the society needs within the country, and you're going to be completely dependent on the other one. It's like food. It's like many other goods. But people have not yet understood the size of the investment that you have to make to get to retain that, I'd say, independence or ownership. So once they realize, it might be a little too late. Yeah. It's like with the speed. Again, it's speed. And it's similar to what we've observed with social media, where now the power is in a few large corporations, and you don't have the ability to be represented in the way they are handled. Well, in AI, it's somewhat similar. If you had services, if you had your own technology to advance science in the direction that might be helpful for society, in a way that is helpful for the cultural local ecosystem, well, maybe you could gain from that better. Mm-hmm. I think this is clearly done by the Middle East. Mm-hmm. They want to have their own cultural impact on those tools, their own ability to define what they want for themselves, and make it at their disposal of their own people. And if it can be helpful for the others on the planet, so be it, and even better. So they understood that, and they're able to do it. So we might have the will, but we might not have the means to do it.
The means, yeah. I mean, there, at least locally, the good news there is that we now have this massive machine in Switzerland, the Alps infrastructure, which we can use for research. So that's very good. But then, yeah, I think that's great. And if I understand the story of that correctly, again, we somehow got just lucky, the right people being at the right time, knowing the right people. But now is really the time to actually already think about version 2 and version 3, right? Because things are happening so fast and the scale is going up so rapidly and massively.
The lifetime of those machines used to be much longer than today. Similar to your computer, similar to your phone or whatever, but even more so in this type of context. Because speed is so important, all the manufacturers are trying to outperform their previous product. And so the lifetime of a given supercomputer like Alps and so on is now shortened. The type of calculations that you do on it, the type of simulation that you do, the type of research you do on it has also evolved. And AI in itself has a higher pace of development. And therefore, the infrastructure itself will have to evolve at a higher pace. So you have it, but for how long? What's the next one? What's the next one? So without wanting to sell what we do at Cerebras, I can tell you that all the manufacturers are trying to outperform it and get better at it. So yeah, you're going to have a good tool. yes, you're going to be able to do research on it. For how long that research is going to be um, well sustained by that infrastructure? In many cases, research doesn't need that supercomputer. You can do that on a laptop. You can do that on equipment that you have maybe in a small data center. And some of it, actually the most impactful one for large societies, is usually done on very large infrastructure.
Yeah. Well, we of course are extremely grateful still for the compute at the moment. I mean, training large medical models in a completely transparent fashion, and large sort of Swiss models, and also just doing the really the foundational research that is needed that you can't do in any other way. At least, I mean, not on just a few machines, but you need hundreds or thousands. I mean, in the same spirit there, what's your view on the role of research universities? I think overall, I think the universities are well, the importance is well understood. I mean, you are an alumnus yourself. You know, of course, perfectly well the importance of education and so on. But it's also interesting to at least also historically see that every time people talk about the dynamics of how a certain business ecosystem came about, it's nevertheless quite striking. This always happens in the vicinity of a university, and sometimes actually what I'm also noticing, it's maybe not just a university, but it's very often university clusters, right? So you have the Bay Area where you have sort of the Berkeley, Stanford, UC. You have the East Coast where you have MIT, Harvard, and other universities. I think we have a pretty good game going on here in Switzerland with EPFL, ETH, and the local universities. And now France, every time they talk about their AI revival and how they're positioning themselves, immediately you read about the École Polytechnique and all these universities. Now, I'm, of course, a bit biased. Well, so I'd like to hear from you, and please be completely frank, right? What are universities doing that's useful, and what are they doing that's not useful, or what, maybe put more positively, what should they do more to help also entrepreneurs and general society to thrive in this coming AI revolution?
Well, the first role that they serve for the industry that they can see, they provide well-trained engineers that have a better understanding of the latest state of the art than anyone you can hire. When you are in the industry and you work on something, you don't work on something else and you don't see anything else. You often see just what you're doing, and unless you are in a research center within a private industry, you don't have access, or you don't have the time to really scope the field as much. And so universities are really a good center of aggregation of latest state of the art and providing resources that are aware of that state of the art. Often those resources are just clueless on how to behave in a private environment, though. And it's okay. It's okay. You don't need to train them to be in the industry. I think some universities do that better than others, and they're well-training students for that purpose, and it works well. And I don't think everyone should be trained for that, and we can, in the private industry, transition those competencies into something that can work well. What happens is we tried, in the US at least, to work with a couple of universities, and the interaction is very difficult for a startup. On one hand, if it is a project that starts in a university that you bring to a startup and you're trying to make flourish as a product and in the industry, you can actually work that out very well with the university. On the other hand, if you are a company trying to leverage the competencies of a university, we found it harder because the objectives are different, the incentives are different. The company wants a product that works in 6 months. The university needs to publish a paper and actually divulge some of the information right away to really keep up with the advances in the field. And so those two are sometimes orthogonal and hard to reconciliate, which means that very often the interaction is really from a research center with another research center and not with an entrepreneur itself with the university. I've seen that. The other is, well, sometimes we have no clue what we're doing in the private sector. We have no idea of a problem in depth. And so we go back to university to have students research or trying to understand the problem we're facing and have a more academic project with them, not to realize a product, but to understand a physical behavior, material science behavior, or a mathematical problem, a challenge, or a software environment that needs to be better defined, or an architecture that needs to be defined. So those are projects that are critical for understanding. So they provide the understanding, not a product. They don't provide a solution to a product necessarily. They don't act as a service in that way, but they act as a service for understanding. And that is critical because very often you cannot afford that in the private sector unless you're a very large corporation that has its own internal research center. You cannot afford that. Mm. And having that nucleus of both manpower suppliers and understanding suppliers in an area where there is enough, I say the terreau, I'll just say that in English, enough a good earth to make that grow is essential. Is essential. We tap into those universities ourselves. We go and hire interns for exactly that purpose, to get the latest and greatest in techniques of machine learning. So getting students, PhD, even professors that can come to our company and help us in that sense. And some of them go back to the academia too. So having that dynamic of coming, providing value to us, learning a bit more, going back to academia, bringing back that value to academia, and having that loop, ongoing loop, is critical too, at various ages and various stages in the career of anyone. Mm-hmm. Is really critical. We love that. Mm-hmm.
And so you're, of course, specifically, I guess, most of the people you hire are coming from rather technical, engineering-oriented schools.
Given that our company has been, for many years, almost exclusively engineers, we do have human resources, product marketing, product management, and other fields that are sales that are now becoming less and less advanced technique job or technical job, and more related to getting to the market type of job. We hired a lot of technical people. Now a little bit less, actually still many, but proportionally a little more on the sales and outwards facing side of the company. And the research, we do research too. And we have a small research team, and we leverage that research team to provide white glove services to customers. So we allow customers to get direct access to research teams so that they can transfer their vision into a mathematical solution, broadly speaking, and then leverage the underlying infrastructure that we provide. So they create that bridge between the two. And universities are really good at providing that know-how. And then we are also providing feedback to the universities. We have many people actually doing training, going back to university and providing training sessions and enabling diversification of of the know-how related to a given infrastructure.
Mm. And have you found it harder over time to hire from universities? I mean, the reason why I'm asking is, if you look, I mean, I don't have the hard numbers here, but it seems like if you look at the importance of technology, right, overall and in industry in particular, I mean, there has been an explosion, right? I mean, sort of the old saying, there are tech companies and then there are other companies who don't know yet that they're tech companies, which may be a bit over the top, but right, is pointing to I think an important phenomenon. At the same time, if I look at schools like EPFL and so on, sure, we're growing a bit. I mean, there's only so much we can grow, but it's not that you're seeing 7 schools like that popping up left and right. So
Here,
yeah,
I've seen that in UAE, for example, where I see the dynamic of the building of schools, like huge university being built, they pop up like startups.
specifically to further the talent pipeline to their local industry.
Yes, and what's actually more frightening is that they're making things very attractive for talent to go there and teach there, and then you get research teams that are extremely advanced than in those environments.
But why is that frightening?
Because it creates a vacuum for the rest of the world. Right? We knew about the vacuum cleaners of university talent in the tech industry.
Yeah.
Google, Meta,
Yeah.
to a certain extent Microsoft. They really vacuum things up, right? And we knew them well. Now it's starting to become other players creating a university, not within a large, I would say, private company or even now public, for those large ones like Google that has research teams, or an old IBM might have research team inside it, right? So they have those, but now there are new ones coming where they actually create universities as opposed to creating a research center within a company. They create university, but then they attract a lot of talent.
Attract a lot of talent. So the war for talent is not going to stop anytime soon.
No. But the good thing is that it creates more resources with talent, which is gonna serve the industry well, and then they're gonna go back to the university in the same way and nurture that effect of growing.
Good. There's a lot of things we could still talk about, but I guess we have eventually come to an end. I want to ask you two personal questions in terms of advice. On the one hand, for students, young people. On the other hand, perhaps for more established leaders. Though I guess those will anyways quickly merge. So what sort of advice would you give people now starting out from a university, or perhaps also somewhere else, entrepreneurs? Just people at the very beginning that are looking at this amazing development with some wonder, but also perhaps with some concern. What's your advice to them?
Do what you like, and do it with people you like. I think that's one of the major elements. Try it out, but don't stick with what you're comfortable with. Do what you like, but trying to like many things. Try to explore a little bit more and be open to something new that comes your way, and try it out. And then try to stick with the team. If you can find a good team you like to work with, it helps to stick with that team, and as a team to move around. Not always easy in some environment. It's easier said than done, but it helps. That's the first thing, and it's very general. You can apply that at any time. Now with AI being in the mix, so happening so fast, it's hard to tell what to do. There are so many opportunities. You can see the devil everywhere. If you want to search for it, you're going to find it. But you can just as well find so many good opportunities that people have not thought about. that has never been as great to try things out. I've seen people coming up with ideas, and in a couple of days being able to create a prototype with that idea, and then grow it. And if they can't grow it, maybe pass it on to someone that can. Don't be afraid of surrounding you with the right people, with talent, better than you if possible, and do go with that. I've always loved to be surrounded by people better than me, and be curious about what they can, if they cannot do, and trying to understand what they do, because it feels magical at first. Also, I just went from academia directly after my master. I went directly into the private sector. I found that convenient for me, might not be for everyone. A PhD can be done at any age. I've seen people at late stage of their career and decided that no, they want to go back to some time in the academia. Why not? I don't know. I don't have enough experience into going back to academia to see if it makes sense or not. I've not done it. I've seen that happen a couple of times. Yeah, have fun, man. Have fun. There is so much you can do, and have fun with people you like to be with. That in the end, that's really
what it comes down to. It is actually interesting that sometimes people feel like everything's been said and done, and that's frustrating. And now it seems like almost the opposite dynamic. It's like everything is being questioned because AI sort of puts everything on its head. And that can also sometimes be a source of frustration, because now the clear direction is not there anymore. But really, I think I agree with you. The way to think about this is that it's such a new surface of opportunities. Well, what a great time now to be young and entrepreneurial.
Maybe some when you're young, you have nothing, you earn nothing. You might be in a financial constrained environment. Might be hard to get by, and you might think, oh, I need to create something to earn money. Stop there, right there. Don't do that. Do something for yourself, for the good of doing it, for having fun doing it. The money will come. Yeah, you might need money to start, so it's a chicken and egg sometimes. But once past that first stage, you'll see that just go with it. It will come. And don't lose focus on the ball. Don't look at the money. Chasing the money never really works well. Rarely works well. Chase the fun.
And for more established leaders, I mean, for many of them, of course, it's also a turbulent time. The ground is shifting. What is one to do in such a situation, or just in general? I mean, not only with AI, but I mean, you obviously led large teams through valleys and hills. So what's
I'd say that I never employed so many diverse people than at this company. I've never seen such a demand for various type of skills than in this company. I thought that one product would be one skill, or I was a little narrow-minded in that sense. And here, I see so many opportunities for diversification in the type of work that you can do. So leverage what you've done, leverage what you've come up so far. I'm sure that if you don't feel comfortable somewhere, there is another place where you will feel comfortable. Just keep looking. Staying where you are and just stagnating there, it's not the right way to do it. I also would say talk about it. There is the fear that if your employer knows that you're not happy and you start looking somewhere, you're going to get fired or whatever, you're being in trouble. I don't think it's a good thing. If it's the case, then you better get off right away anyway. talk about it. Talk to your coworker, talk to your manager, talk to your mentor if you have one, talk to the industry leaders and talk about it. You'll see. At some point, you're going to find a direction that you get pulled to. Go with it. Go with the flow in that direction, and you'll see you're going to swim faster than the flow at some point and fly. Don't be shy in that way. Don't get stuck. Keep doing what you like, and if what you're doing is not what you like, obviously you don't want to change right away and change your mind every day. Or if you pick something, trying to get through with it, that for sure, stick with it. But at the same time, don't get stuck somewhere where it's really not interesting. And maybe you can make it interesting. Just don't go somewhere else. You can actually change it and make it interesting. The adventure at Cerebras is a perfect example. We did it knowing that it was extremely high risk, and everyone that was hired was, let's have fun, let's do this. We're going to fail. When is it? When we're scheduled to fail? Oh, next week. Okay, well, do that next week, the week after. Yeah, we're going to fail that way and that way and that. Okay. And have fun doing it. Yeah.
Excellent. Well, thank you so much. If people want to learn more about you or Cerebras, where would you point them?
Cerebras, it's pretty obvious. You can go on the cerebras.net website, or you can try the inference.cerebras.ai just to get a sense of what an equivalent of ChatGPT does on our platform. That's one way. We have many links to research that we've done, to customers that we have, to use cases that we've done. So you have a pretty good set of links. There's YouTube videos you can follow there a lot. For myself, I'm not very present on the web. I just have a LinkedIn web page probably that you can reach out to me, tell me what you'd like to do, and I'll try to respond and help you. Ideally, just put a word as opposed to just connecting, because otherwise I don't really know what you want. Just give me a few words of what you're looking for, and I'll try to help.
Excellent. Well, thank you so much, JP, for coming. It was a pleasure to talk to you.
Thank you for having me. This was a pleasure.